this problem, given logs with all this logs right here with the timestamp, and this x and y, which indicates friends. So our goal is to find the earliest moment when everyone becomes friends. So basically we need to connect all of them and get the timestamp of the last connection of it. So very straightforward union find type of question data structure. So n is the number of people, and yeah, that's about it. So I have implemented union find in here. I've covered this union find in previous videos, so I will just go over it quickly. We have two main methods in here, find and union. Union basically takes two vertices and connects them together, and in here I did a little bit of modification where it is returning a boolean. So in case when they are together, that means there is a cycle, so we're returning full, and in here we're returning true. So that's about it about union find here. And what we need to do is that in this problem, nowhere it mentioned that given timestamp is logged, sorted. So first thing first, we need to sort this by its timestamp, and then start connecting these connections. And in the end, when it is in the last connection, then we just need to return given timestamp. So let's jump on it. First thing first, let's do our sorting of this logs. So for that one, let's take log 1 and log 2 and do lambda expression on it. Integer compare. So we are comparing this log 1's 0, because in index 0 it's a timestamp, so we are comparing by its timestamp and sorting it. Now it is, since it's sorted, we could actually start reversing it. So int I log and given logs, and first one, it's a timestamp, that is in our log 0, and then we have our x and y, which are the friends. So friend a equals to log 1 integer friend b equals to log 2. Now what we can do is that we can call our union in here. So prior to that, we need to define our union find class, new union find, which takes this number of people in there. And another thing, initially all these numbers are our groups. So in groups, initially it's all of them are n size, because each of them will be grouped itself, so they're scattered in disjoint sets. And once we start to combine them, and when these groups become, you can say groups count, when this groups count becomes 1, that means all of them were they became friends. So they were combined together. So there we can know that this was the last connection in there. So you can say if we were able to combine friend A with friend B, that means there is one less connection with this in this groups count. So you can just decrement this, and we can actually see if this, when this group's count becomes equal to 1, that means all of them are connected. So our we can just return timestamp from here. So if everything doesn't connect, because sometimes there might be cycles or not cycles, there might be two different, like some sets might not be connected together. So in that kind of cases, this group's count will be more than more than 1, and in this one it is saying everyone becomes friends. So the goal is to become this one, but in those kind of cases where it doesn't become, then we'll just simply return -1 as they were requesting in this. So let's run our code. Perfect. So as far as time complexity in here, so time complexity, we can say that we are sorting. So this is sorting by these logs. So we can say O L log L. So OL times log L. And we can see that we are also going logs by logs. So this is OL, and then another thing in our here, this find and unions, these are amortized time, ON, so very close to constant. And we also have our N, so where we are going in here. So overall time complexity is, so N is the number of people, so overall time complexity is ON plus OL times log L, and the rest is just kind of like close to constant. And as far as time complexity, space complexity, so arrays.sort, it utilizes quick sort, and for that it uses O log L space for it. And also we have created some data structure where we're holding number of people, so ON plus O log L.